to explain this concept of memory, I have divided my page into two sections. So here we have the external section and the internal section. So here we're gonna this is gonna hold all the features of the Arduino that are external, which are the pins that we see that can send out signals to our LEDs or other components that we are going to control. And here we're going to have all the features that are associated with what happens on the inside, or when the Arduino is thinking. Memory is very easy to conceptualize. When you speak of memory, just imagine that the Arduino has a room, and in that room it's full of shelves, and in these shelves the Arduino keeps information on its features. So in your brain as a human, imagine that you have a room that is full of shelves that keeps information about your hands, your feet. It keeps information like how many fingers you have, how many toes you have, how tall you are. And with this information that it keeps over there, it uses that information at certain times your body to assess whether you can be able to do certain things. With that, so the information on hands and feet, those would be your external features. Also with internal features, it can keep information on how happy you become when you see a dog, what excites you. So all the information that has to do with things like your emotions and intelligence, they'll be kept in a room with shelves of information based on your emotions, your intelligence, and whatever happens in your brain. Okay, so these are the shelves of our two sections of memory. So the page is the memory, and then now we've divided our memory into two sections that holds information based on different features that we have available on our Arduino. So then now, what it does, because it's quite a clever machine, it labels each shelf on the memory. So this will be number 1, this would be number 2, location 3, all the way up to 9. The same will also happen for the internal side. All the way up to number 18. So this is memory, and these are the shelves that the Arduino has to put its information based on how you've programmed it. Okay, so I want to go back to the instruction, our famous instruction that we had, which is our pin mode 8 output. So how does this actually play out in memory in the background when you write this instruction? So when you specify this particular instruction, what the Arduino says is that, okay, so now I know that I am gonna have to remember information about a pin. Oh, a pin is an external device. So it immediately knows that I'm gonna look at this side of the room. And then it says, okay, pin number 8, I want you to set it as an output. So now you've given it information to remember, so that this information, it remains the same in its memory, and it remembers that this is how things are configured. So what it does is, if this is the first instruction on your code, it's gonna look at external memory. That's the first step, because it knows that a pin is an external device, and then it's gonna go into the shelf of external memory. Since this is happening for the first time, it's gonna go, okay, the information of pin number 8. The information of pin number 8, I want to put it in this shelf. So now it knows that, okay, at label number 1, I have information on pin number 8. And then it says I can also add in more information about what is happening at pin number 8. And then it's going to say the programmer wants pin number 8 to be used as an output. So it keeps it there. So that's how it knows that every time you use pin number 8, it is an output. And I'm storing that information in shelf number 1, the shelf that is labeled 1. So with a second instruction that you can write from this, you can write after this, is maybe you want to set up pin number 9 as an input. So when it reads that instruction and then it remembers it, it's to remember it, it will put that information on pin number 9 in shelf number 2, and maybe this time your pin number 9, you want to have it as an input, like that. So then this is how it remembers that when I am reading the script, the external features that I am using are labeled like this. So when it reads this line of code, it says, okay, setting this as an output, setting pin number 8 as an output, and I'm going to store that information in shelf number 1. Setting pin 9 as an input, I'm going to store that information in shelf number 2. And then, so that's how it always remembers this. And when it reads the instruction, it stores it into memory. So that's why if after void setup, you never have to do this instruction ever again, because it keeps it there. Once you learn how to walk, you don't have to learn how to walk, because it's in your muscle memory. And when we walk, that is an external feature. People can see what's going on. Then we are going to go on to the internal memory. So in internal memory, you're just going to tell the Arduino in this example that I want you to keep in mind how many times the LED goes on and off. But then, what tells the LED to go on and off? What tells the LED to go on and off is actually pin number 8, because it is an output. That's what sends the signal to the LED. And then what you need to do is, you're going to tell the Arduino, hey, I want you somewhere in the external memory region to remember how many times the LED goes on and off. But then now, the difference with this is that with pin number 8, it's something that's available, so it's something that's available and you see it. So, but here, it's quite something that's not there. You sort of need to specify a variable or a bucket that will store how many times the LED goes on and off. So that would be a variable. Now we want something that keeps information on how much the LED goes on and off. So just imagine that the Arduino puts some form of bucket, and then this bucket is labeled N. I'm going to label this bucket N. And then so every time the LED goes on, this bucket N increases by 1. So the value in this bucket N, it starts at 0, and then when it goes on, this value at this bucket goes to number 1. This exists on the internal side. So when we talk about variables, we're talking about something, an instruction where you tell the Arduino that in your internal memory, I want you to reserve a section for me. And in this section, I will store how many times the LED goes on and off. And we need to put a label for that section. And in our case, our label is N. We're going to call that section N. So when we say, we write an instruction saying that I want you to go to your memory, create and reserve a space for me, and I want to call this space N. So the same thing actually happened here. It's just that it actually knew that I already have a pin 8. But then what this also says is that, okay, you have something called pin 8, go to memory, shelf number 1, reserve that space for information concerning pin number 8. Here, we're saying that in your memory, please keep a space for us where we are going to store values that count how many times the LED goes on and off. Then, when we specify that, that is called variable declaration, because we are declaring that this space is reserved for this variable called n. Then when it reads this instruction for the first time, we would like to specify a starting value for n. So we maybe say, in the first round, n starts at 0. Then what's going to happen is that it's going to go to its memory and then put the value 0. Because remember that this space is reserved for information that contains n. N here is just a label. This label tells Arduino that when it reads the instruction, go to the shelf, look for a label called n. Then when you see that label called n, put a number 0 over here. On the other hand, this one says, go to the external side of the memory. Go to shelf number 1 and then create a space and enable it pin 8. And then over there, you're going to store all the information that has to do with pin 8. When pin 8 goes high, it will remember it there. When pin 8 goes low, it will remember it there as well. So the same thing is happening over here for n. So when it starts here, it says, okay, let me go to label number n and make that 0. Then it goes and reads the instructions. And then we further tell it that when the LED goes on, increase the value of n by 1. So it starts at 0, and every time the LED goes on, increase that value by 1. So it starts at 0, the LED comes on, we increase by 1, and the value of n now is going to be equal to 1, because 0 plus 1 is 1. So now the value that was here was 0. Then what it's going to do now, it's going to change that value. It's going to scrap out this old 0 that was here, and then it's going to put a 1. Okay, the code runs. Because it's in a loop, it comes back again. Now when it comes back, the value of n is 1. But then it knows that when I come back and the LED goes on, I need to add this by 1. And then 1 plus 1 here equals 2. Then now it goes, okay, now the value of the label n has changed. It goes to the memory, it goes right through into the internal side, it looks for the label of n, it goes into that region and it says, oh, in that region I had a 1, but then the value has changed now, and the script has told me to put a value number 2. And that's how it works. That's how memory works, because when you do changes, whether it's external or internal, it keeps it in its memory. So when you write your code, you must always keep in mind of what's going on in the background, because your instructions change something in the background. If you can even tell that when I receive a signal at pin number 9, I want you to make the LED go on. In that case, is how it will work is when it sees that, okay, so pin number 9 is an input, correct? Am I getting a signal from that? Then it says, oh, I'm getting some signal, I'm hearing something. Okay, since I'm hearing something, I want you to go to memory, look where there is a label called pin number 8. When it gets into that region, so now it knows that, okay, I need to be here, Then it looks at the information that's available over there. It says, okay, pin number 8 is an output. Since the instruction told me that if I get an input from pin 9, here I must execute the output function. It will then turn the LED on. So that's essentially how memory works, and that's how these artificial intelligence systems can interpret things, because it knows that, okay, I need to request this information at the back of my mind and then compare it. As I conclude with this, I just want to say that remember that this is only a side lesson, and everything that I'm explaining in this lesson will come together as we go on with the series. But if you understand this fully, it's good for you. And as I teach you how to program more and more advanced scripts, I'm gonna take you guys through everything. I will repeat some of the stuff, so if you didn't get much of it, it's still good.